In this video, we are going to discuss some applications of total internal reflection. That includes prism binocular, prism periscope, cat's eye reflector, and optical fiber. The applications of total internal reflection is more than this. The others we are just coining 4 of them, and the following video illustrates the applications.
Applications of total internal reflections. Prism binocular. Prism binocular. If you want to use a binocular, to enlarge something which is very far away, then you need to have two pieces of lens. There's one lens here and one lens here. Two pieces of lens. If you want to get a brighter image, and a bigger image, these two pieces of lenses, the distance can be quite far away. Quite far away. Maybe it's like maybe it's a 50 cm or 100 cm. It can be quite far away. So if it's quite far away, if you straight away build the binocular by using the lens, then the binocular will become very long. It will be something like this. One piece. Again, there's another one. So it's very long because the light ray need to move a certain length of path. Then only it can go to the second lens. So it's too long. So one of the methods to reduce the distance between the two lenses is by using prisms to reflect the light. So the light can go here, reflect it back and go here and go here. So then if it's reflected, for a few times, then the distance maybe from here to here is already 50 cm. So then the binocular don't need to be very, very long. Then you may ask the questions. You may ask the questions. Then why we want to use total internal reflection? Why don't we use let's say mirror? Why don't we use mirror? Now the reasons that we don't use mirror is because if you use prism for total internal reflection, there are two advantages. One is brighter. It's brighter. Why? Because almost 100% of the light is reflected. 100% of the light is reflected. But if you use mirror, just part of the light is reflected, not 100%. Maybe 80%. 80% of the light reflected. But if you use total internal reflections, then 100% of the lights will be reflected. That is the first reasons. Second reasons. For total internal reflections, there is no double image. Now, what is double image? Let's say you use mirror. Mirror, usually there's a piece of glass. And at the backs of the glass, then we have layers of silver. The silver is the substance that reflects the light. So when light ray come, the light ray, let's use another color for the light ray. Let's say we use an orange color, use straight line. So when the light ray hit on the glass, it will be reflected. It will be reflected by the glass. Because the glass is transparent, it may undergo refractions, go inside and then reflected by the silver, and then undergoes refractions. So from here we can see that one light ray split into two. So then this will form double image. Double image. This image is very close to each other. Normally you won't realize, but it will make the image become not very clear. Not very clear. That's why we use a total internal reflection, because total internal reflections, no double image. So no double image. This is the advantages of using total internal reflections over using mirror. So prism is used in binocular to shorten the length between the eyepiece and the objective lens. This is eyepiece, this is objective lens. And the reflected ray produces an upright image when reaching the eye of the user. So by using this total internal reflection, you will get an upright image. Okay. So by using a normal telescope, you will get inverted image. Okay, inverted image. But after the reflection, you get an upright image. Periscope. Okay, so this is the diagram of periscope. Okay, so you can see that when light ray going in, it will be reflected, and then another light ray coming in. Okay, it will be reflected. And then you can see that the orange light is on top. The green light below. Means that the image that you see is upright. The image that you see is upright. So prism are used to construct a periscope. The light ray entering the periscope undergoes total internal reflections. The image seen through the periscope is upright and same size as the object. Okay, so that is for a prism periscope. Diamond. So when you see diamond, okay, it's very shining, right? That is because the critical angles of diamond the density is very high, okay, very high. So therefore the critical angle is very small, 24 degrees. So as a result, total internal reflections can easily happen. So multiple total internal reflections makes diamonds sparkle. Let's say you have a piece of diamonds, okay, and the design is like this. Yeah, there are certain angles that they will cut to certain angles, this diamond. So when there's light ray come in, let's say the light ray come in, okay, they come here, and as it does not go out, okay, it will be reflected, and then reflected, okay, and then reflected out. You see, it can easily undergo total internal reflections, okay. So the light ray can be reflected back easily and come out from a different surface. Okay, you see this surface. Okay, there's a lot of surface that you can see this light come out. So it makes the diamonds look sparkling. Cat's eye reflector. Okay, so you see this one. Okay, all these are the cat eyes reflector. So the cat eye reflectors on road reflects the light ray from the headlamp. So if you drive your car, okay, you on the headlamps. So the headlamps hit on this cat eye reflector, and then the light will be reflected back to the driver's eye owing to the total internal reflections. Okay, so this is another diagram of the cat eye reflector. Okay, you see this is the light from the headlamp. So it go into the cat eye reflector, go inside, and then undergoes reflections, total internal reflection here. Total internal reflections come out and then go back to the eye of the driver. So therefore the driver will see the light. Okay, you will see all this light. It looks like it's the lamp. Okay, but actually there's no lamp. Okay, this light is come from the headlamp of the car itself. The cat eye reflector. Optical fiber. Fiber optics is widely used in telecommunications and medical instruments such as endoscope. In optical fibers, the light rays undergoes total internal reflections if the path is not straight. Okay. Now, if you're using unifier for your internet, then you are using optical fiber. Okay, you're using optical fibers. So optical fiber actually is a piece of glass, but there's a lot of glasses there, okay. It's a piece of glass, and then this light of different frequency. Okay, the frequency of the light is the informations. Okay, it's the informations. So when it go into the these optical fibers, and inside this optical fiber there are two layers. Okay, there are two layers. The inner layer is the glass. Okay, it's the glass, and then we have an outer cladding. This outer cladding has low refractive index, means that the light ray when it go inside, okay, so it will be from denser to less dense. From denser to less dense, then it can undergo total internal reflections. Okay, total internal reflections, total internal reflections. Okay, the light ray come out. So the inner layer with higher refractive index, the outer layer with lower refractive index, and you must know this. So then the light ray undergoes total internal reflections and come out. So this is very useful in telecommunications. Okay, to transfer informations. Information is the frequency of the light. So we change the information to the frequency of the light, and then we transfer it by using optical fiber. Okay, and because it's light, it can move very fast. We know that light move very fast, right? Okay, and then because it's inside optical fibers, so very little energy is lost in the process of transferring. Compared to by using copper wire. Copper wire, because it has resistance, So a lot of this energy will lose in between the 2 points of this transfer. So that is optical fiber.